times its atomic mass 6/1. Repeat the second one. Same thing here. 12 over the sum 13 times 7/1. So when we solve, we have 6/13 plus 84/13. Taking the common denominator, we have 90/13. Solving this, we get 6.92, which is the relative atomic mass of lithium. Okay, we take a third question or a third example. An element S with relative atomic mass of 16.2 has two isotopes, S16 and SM, present, with 10% and with 90% and 10% relative abundances. Calculate the value of M. Look at this problem on the whiteboard. It's not a difficult task. For us to solve this, we have two isotopes, S16 and SM. But in this case, we are given the relative atomic mass of S to be equal to 16.2. So we are not looking for the relative atomic mass. So we are also given the percentage abundance of isotope S16 to be 90%. The percentage of isotope SM to be equal to 10%. So this problem now, we are looking for M, and M represents the atomic mass of this particular isotope. To solve this problem, we still follow the process of getting relative atomic mass. 16.2, which is the relative atomic mass, is obtained by multiplying each percentage by the atomic mass. We have 90/100 times 16/1 plus 10/100 times M/1. Okay. So 0 can cancel out 0. 0 can cancel out 0. We have 16.2 equal to, we multiply the numerator, 9 times 16 giving us 144. We also multiply the denominator, 10 times 1 giving us 10. Going over to that side, M times 1 gives us M also, 10 times 1 gives us 10. They have a common denominator, we bring them under one denominator. We have 144 plus M/10. Having done that, we continue from here. We have 162.2 equal to 144 plus M/10. So since we have one denominator on the right hand side, and what we have is 1, also one denominator, 10 there and 1 there. We cross multiply. So 144 plus M times 1, that makes no difference, equal to 116.2 times 10. 144 plus M will give you 162. So M value becomes 162 minus 144, giving us 18. So the atomic mass of this isotope is 18. Okay? We're now going to take one more problem for today's class, which happens to be pretty difficult compared to the other problems. We have an element Y with relative atomic mass of 10.8 has two isotopes, Y11, Y10, and Y11. Calculate the relative abundance of each isotope. See, in this problem now, we don't know their relative abundances. Had it been that they gave all this as 50%, 40%, This one could have been 60%, so from 100. But in this situation, none is given to us. So it looks as if it's confusing or a kind of a tricky question. We can still do justice to it. Relative atomic mass of Y is given to us as 10.8. Okay? Having done that, we now look at we don't know their relative abundances. So we say percentage or abundance of Y10, we don't know what it is. So we can assume it, subject it to be a value. Let the percentage of Y10 be as, okay, A% or known value. Therefore, percentage of Y11, how to find it? To get the value, since there are two isotopes, we will have to get this one, you subtract this from 100. 100 minus A%. So we'll follow the same process of calculating relative atomic mass to solve it. But this situation, we are given the relative atomic mass as 10.8. We therefore say 10.8 equal to A% of 10, meaning A over 100 times 10 over 1, plus 100 minus A%, which is 100 minus A over 100 also, times 11 over 1. Solving this, 10.8, let us multiply the numerator. A times 10 gives you 10A. 100 times 1 gives us 100. Opening this bracket, 100 times 11 gives us 11 double 0. And 11 times A gives us 11A over 100. They have one common denominator, as you can see on the screen on the whiteboard. So we take one denominator, 10A plus 1100 minus 11A equal to 10.8. So having done that, we now continue solving. 10.8 equal to this value and these are like 10, they're carrying A. So we can as well say 10A minus 11A, that will give you minus A plus 1100 all over 100. So having done that, what then do we do? We have a one denominator here, and we also have 100 as a denominator there and 1 here. So we can now cross multiply. Have minus A plus 1100 equal to 10.8 times 100. Minus A plus 1100 giving us 1080. So minus A will give us 1080 minus 1100. Minus A is minus 20. That means that our A becomes 20. Minus cancelling minus 20%. And what does A stand for? A stands for the percentage of isotope Y10, which is 20%. Then percentage of Y11 is 100 minus A. Putting the value of A here, that will become 100 minus 20. That will give us 80%. You see, that's the perfect solution. So look at this, see that the working is clear and very perfect. You too can practice that, you too can know that. Then relative atomic mass of an element or relative molecular of a compound can be determined instrumentally by using what we call the mass spectrometer, a very technical analytical instrument. Okay, now the relative atomic mass of an element is not a whole number. If you look at all the values we do in calculation, they are very decimal values, not a perfect whole number. Why? Because of the existence of isotopes with different. Like for instance, this is 10.8. The abundances is 20% and 80. The relative abundances are not equal to each other. So the existence of isotopes with varying or different relative abundance. That is why the relative atomic mass of an element is not a whole number. Okay, having done that, we have come to the end of today's class on isotopes, relative atomic mass, and how to determine mass number, atomic number, how to differentiate between a neutral atom and an ion, which the difference is based only on the number of electrons. So you try to subscribe to this YouTube channel and keep on watching, like the button, and then send your comments as we continue to improve in our tutorial online class. Also, if you have a topic or you have a question, you can still forward your question online, or any topic you want us to treat, be it topic under high school, secondary school level, or topic for tertiary institution. As we proceed, we are going to still move to topics that involve that are for those in year 1 and year 2 of higher institution. So thank you for watching. Subscribe and keep on watching. Thank you.